Paper 1, Core Pew Mathematics 1, Further Mathematics Advanced, Monday, 3rd June 2019. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. The total mark for this paper is 75. Paper 1, Core Pew Mathematics 1. Question number 1. F of z is equals to that expression there, where a, b, c, and d are real constants. Given that minus 1 plus 2i and 3 minus I are two roots of the equation f of z equals to 0. Show all the roots of f of z equals to 0 on a single Argan diagram and find the values of a, b, c, and d. So if you look underneath, I've put for any complex number z equals to a plus ib plus bi, the complex conjugate of the number is defined as, we can call it z star a minus bi. Remember, there's a minus there, and this one has a plus. That's how you define a complex conjugate. It's a plus there, and this one is a minus. We're going to be using that. So the conjugate roots, if one of them is minus 1 plus 2i, the other one will be minus 1 minus 2i. Remember, we put the minus there. So if one is minus 1 plus 2i, you change that plus to a minus, it becomes minus 1 minus 2i. So that gives you the next root. If one of the root is 3 minus I, which is given in the question 3 minus I, the next one will be 3 plus I. You change that minus to plus, so you get the other root. And it is the 4 roots, 1, 2, 3, 4. It says show all the roots on a single Argan diagram. This is an Argan diagram. You have the real part, which is like what we used to have the x-axis, and the imaginary part, which is like the y-axis. So we have minus 1, 2. So if we want to represent that one, we'll come here. So minus 1 to the left and 2 up. So that's the first one. Minus 1 to the left and 2 up. The next one, minus 1, minus 2. Minus 1 to the left and minus 2 down. So this one is representing this one, and this representing that one there. Next one, 3 minus 1. 3 minus 1 is this there. 3 to the right and minus 1 down. And 3, 1. 3 to the right and 1 up represent that one. So that's your Argan diagram. For part B, it says find the values of A, B, C, and D. So we got the f of z equals to that. And we got those 4 roots. So what we want to do now is we have z minus the first root times z minus that second root. So we do those pair together and we multiply them out. And a quicker way to do it is we want to get rid of this minus sign to make it easier to get rid of the minus sign there. So if we change this one to minus 1 there times minus 1. So if this one becomes a plus, change that to a plus. This one will become plus 1. And this one will become minus 2i. Because minus and minus will be a plus. And minus and plus 2i would be minus 2i. And this would be a plus. You change that minus to a plus. And this would be like minus 1 times minus 1 will become plus 1. And minus 1 times minus 2i will become plus 2i. It just makes it easier. Now you can multiply it. Z times z is z squared. Now careful here. You're multiplying z times this bracket. Z times 1 plus 2i, you treat it as 1. So 1 plus 2i times z. So z comes outside, and then in bracket 1 plus 2i. That's how you write it. That's very important. For the next one, it's minus 1 plus 2i. You treat it as one thing times z. So you can write the z outside and the minus 1 plus 2i in bracket. And then after that is 1 minus 2i times 1 plus 2i. You can treat this as difference of two squares. So that will give you 1 squared plus minus 2i squared. Or if you look up there, you can just multiply it out, expand double bracket, and you'll get 1 plus 4 gives you 5, because I squared is minus 1. Put it in your calculator. I squared will give you minus 1. So minus 4 times minus 1 will give you plus 4. That's why you get 1 plus 4 gives you 5. So we know z squared, z plus z, the pink one will give you 2z. 2zi minus 2zi, the one in green, they'll cancel each other. And then plus 5. So you got z squared plus 2z plus 5. So that's the first one. When you multiply those for the first two conjugate factors. Now, using the next pair of roots, you have z minus 3 plus I, and also z minus 3 minus I. In this case, I'm going to leave it without changing it to plus there, because it's easier to multiply. You keep changing things depending on how you want to make it easier for you to multiply. I can see here, I can do z times z, which gives me z squared. Z times 3 minus I, you treat the 3 minus I as one thing and then times z. So the z comes outside, and in brackets 3 minus I. And because it's a minus, I have the minus there. And after that, minus 3 plus I times z. The z comes outside, and the 3 plus I goes there in the bracket. And don't forget, it's a minus. And then after, it's minus 3 plus I times minus 3 minus I. This minus and this minus makes the plus. And then the 3 plus I, bracket 3 minus I, which you can expand as I've done it to the top right there, like double brackets. Remember, I squared is minus 1. So it'll be 9 minus minus 1. That gives you 10. So you would simplify. The zi will cancel with the zi. I put it in green. It becomes 0. Minus 3z minus 3z would become minus 6z. So you get this second expression, z squared minus 6z plus 10. So now you got the second expression. You put the two expressions together. Z squared plus 2z plus 5 times z squared minus 6z plus 10. So you would expand the brackets to form a quartic. A quartic means polynomial to the power of 4. So when you're expanding it, you can just follow those lines I've drawn there. 1, 2, 3 at the bottom. Z squared will multiply by the 3 terms, 1, 2, 3. Minus 6z will multiply, follow the purple line by the 3 terms, and 10 will multiply, follow the pink lines, will multiply by the 3 terms. So you have 9 terms. So z squared times z squared, the first one, it gives you z to the 4. Z squared times 2z, it gives you this z squared, and 2z will give you 2z cubed, and so on until you get all of that expression there. Now we have to collect like terms. Z to the 4 stays the same. And you look at the one in yellow. The yellow is the z cube. 2z cube minus 6z cube. It will give you minus 4z cube. We look at the ones in green color. 5z squared minus 12z squared plus 10z squared. That gives you 3z squared. And then we look at the ones with the z in them. Minus 30z plus 20z, it gives you minus 10z. And then the 50 is there on its own. Now we want to compare it with the expression we had in the beginning. What A is that 4 there, minus 4. So if you compare it, follow the pink arrow. A is minus 4. B is that which is 3. C is the number in front of Z, which is minus 10. And D is 50. So you state your answers. A is minus 4. B is 3. C is minus 10. D is 50. So this is the examiner's report for this question 1. It says part A was accessible to almost all candidates, with most gaining full marks. So most students could do part A, and almost all the candidates would gain full marks for part A. So that was brilliant for that part A. And it just says a handful of candidates thought the conjugate was, people made mistake. They didn't understand what conjugate is. As I showed you in that question, conjugate, you change that plus to a minus. So students could not get the conjugate correct. So that means they had a big mistake, and that mistake had to be carried forward to do the whole thing. And a few candidates lost marks because of poor diagram. That's easy marks to get in your exams. Use a ruler, draw your diagram neatly. Poor diagram, the failing to indicate a scale or labeling with minus 1 plus 2i closer to the real axis than 3 plus I. So you have to draw the diagram neatly and put a scale and number it. The real axis, the imaginary axis, so that you don't lose that mark. Coming down to the bottom, something which was common. Common errors with this approach were to make a sign error when attempting to apply I squared. What that is saying is that I squared is equals to minus 1. You remember I said put it in your calculator so that you don't make the mistake. So that when you get a minus 1, it would help you to work out when you are subtracting, and you would apply a plus instead of a minus. So very important to check that with your calculator if you're not sure. And then it says some candidates made slips when multiplying out the quadratic factors. And 1 or 2 lost the final answer mark for stating a quartic in terms of x and not z, because it's in terms of z. So the important thing for me here is when you get I squared is equals to minus 1, it changes the sign. And make sure you draw a large diagram and label the axis and indicate the scale, and learn to remember how to get the conjugate. But I'm happy with question 1, part A, because almost all candidates gain full marks in that. So that's how the examiners analyze this question 1.